Welcome to class. Today I'll be giving you a revision of the topics that you're expected to meet in the WAEC exams. And I want to give you shortcuts. In fact, at this time, I'll be showing you shortcuts that you can use to approach your questions, both in the theory aspect and in the objective aspect. So I have a list of topics on the board. In the first segment of this class, I'll be taking topics listed here: stoichiometry, that is mole concept. I'll be taking oxidation number. I'll be taking electrolysis. I'll be taking redox. And then in the second video, I'll be doing periodic table. I'll be doing organic chemistry. I'll be doing solubility. So I want you to pay attention to the very end so that you can get value and be well prepared for your exams. I hope that is clear. So come with me. Let's start with stoichiometry. Stoichiometry is the same thing as mole concept. So at first, I'm going to give you some formulas. I'll give you 5 equations that you can use to tackle any question that comes out in your stoichiometry. 5 equations. Now let's look at that. Number of moles equals to mass over molar mass. Now the unit for number of moles in mole, mass in gram, molar mass in gram per mole. Okay. Number 2, number of moles equals to molar concentration times volume in dm cube. Please take note, anytime you are using this equation, your volume has to be in dm cube, and then the number of moles is in mole. Okay, your molar concentration is in mole per dm cube, or molarity, Molarity is capital M. So there are some questions where they will give you 1 m of H2SO4, that is 1 mole per dm cube. Volume in dm cube. Number 3. Now the only place where you are not going to have to convert your volume to dm cube is when you are doing acid-base reaction and they give you the quantity of acid in centimeter cube and they are asking you to find the volume of base. In that situation, you don't need to convert, all right? You are still going to use both in centimeter cube because you are comparing values, all right? You are comparing the volume of the acid with the base. But when you are given a specific question to work on, you have to convert it to dm cube. Now the next one is molar concentration equals to mass concentration over molar mass. Your molar concentration is in mole per dm cube, or it is molarity, molar, okay? Then your mass concentration is concentration in grams per dm cube. Your molar mass is mole per dm cube. All right? Now, that is that. The fourth equation is 1 mole of a substance equals to 6.02 times 10 raised to power 23 atoms or particles. All right? 1 mole of a substance equals 6.02 times 10 raised to power 22 atoms or particles. And the last one is 1 mole of a gas has a volume of 22.4 dm cube. That means 1 mole of a gas equals 22.4 dm cube by volume at STP. That's standard temperature and pressure, STP. Now, these 2 equations, number 4 and 5, together are called Avogadro's constant. Avogadro's constant. So, any question they are going to ask you on stoichiometry, you can use any of these equations and you will be able to answer the questions without stress. All right, so you can pause this video, write these equations down, try to master them, and you try to use them. We are going to try out some examples right now using this, and then we'll see how to know the exact formula to use to answer the question. So I'm going to put questions on the board and we'll see which one to use to answer the question. Magnesium plus hydrochloric acid, 2 moles of hydrochloric acid to give magnesium chloride plus H2. From the equation, what mass of hydrogen will be produced if 12 grams of magnesium reacted completely with dilute hydrochloric acid? So the first thing you need to do is to inspect the equation given and be sure that the equation is balanced. How many magnesium do we have here? On the reactant side is 1 mole. How many here? 1 mole. Hydrogen here is 2 moles. Hydrogen is 2 moles. Chlorine here is 2 moles. Chlorine here is 2 moles. So this equation is balanced. So the first thing is you rewrite the equation magnesium plus 2HCl to give magnesium chloride plus hydrogen gas. They now say from the equation, what mass of hydrogen will be produced? So we are looking for X gram of hydrogen. If 12 gram of magnesium, so you have 12 gram of magnesium reacted completely with dilute hydrochloric acid. So all you need to do here, this is a very simple question. All you need to do, please note, you are not expected to equate mass. Don't say 12 gram of magnesium is going to give us X gram of this, and then 1 gram of magnesium will give us X, and then you mix it up. No, what you don't equate masses, all right? You only equate number of moles. So that means you need to convert these to number of moles. But before we do that, from this balanced equation, how many moles of magnesium do we have here? 1 mole. So you have 1 mole of magnesium reacting with 2 moles of this to give 1 mole of hydrogen gas. So 1 mole of magnesium liberates 1 mole of hydrogen gas. That's H2. So if that is the case, we need to know the number of moles of this magnesium. And from the equation I've given, this is 12 grams. If you want to convert it to mole, you use equation 1, which is number of mole equals to mass over molar mass. This is the mass. So you divide it by the molar mass of magnesium is 24. So when you divide by the molar mass of magnesium, that's 1 over 2, that is 0.5 mole. Okay? So from here, the balance equation shows us that 1 mole of magnesium will give you 1 mole of hydrogen gas, meaning that the amount of mole of magnesium will give you exact amount also of hydrogen, equal 1, 1. So if that is the case, if this guy is using 0.5 mole, definitely 0.5 mole of this will also give us 0.5 mole of this. Or you could write X and cross multiply. So if you write X here, okay, then you cross multiply 0.5 times 1, you have 0.5 times 1 equals to 1 times X. All right, so your X is 0.5 mole. But this, you were not being asked the amount in moles, you were asked the mass. So you need to convert this mole back to mass. And you still use the equation 1, which is what? Number of mole is mass over molar mass. But this time around, the molar mass of hydrogen gas is what? Hydrogen is 1. Please take note. Hydrogen gas is H2, not 1. So you are going to multiply the 1 by 2. And hydrogen gas is going to be 2. So the molar mass of H2 is 2. All right? And the number of mole is 0.5 mole. So you are going to say 0.5 mole, okay, is equals to mass over 2. So you cross multiply 0.5 times 2. The mass is going to be 1 grams. Do we have that in the option? 1.0 grams. So the mass of hydrogen gas that will be liberated is 1 gram. Very simple. Let us look at one more example before we go to the next topic. If 0.5 mole of magnesium sulfate with X amount of water of crystallization, all right, as a mass of this, calculate the value of X. So what are you going to do in this situation? The number of mole, so what are the parameters given? Number of mole is what? 0.50 mole. As a mass, the mass of the substance is 123 grams. And then this, they are asking us to calculate the value of X. So calculating the value of X simply means you are going to have to find the molar mass of every of these substance, magnesium sulfate, and then number of water of crystallization. It could be decahydrate, whatever we are going to know. All right. So we have to find the molar mass. So can you try to recall from the first set of equations I listed from the 5, which equation combines number of mole and mass and molar mass? So at this juncture, let me say this. When you have a question, the first thing you do is to spell out the parameters given. It is from those parameters that you will now discover the appropriate equation to use that will solve the problem. So here, we need to look for which equation has number of mole, mass, and molar mass. And that is equation 1. And that equation 1 says number of mole, okay, equals to mass over molar mass. Now, let me also say this. Please, for your theory questions, there are certain things the examiner is looking for that is called the scoring point. Scoring points are those things that will attract marks. So not the calculation alone will be scored here. Your parameters, your ability to spell out the parameters correctly will attract marks. Your ability to state the formula you are using will attract mark as well. Then your calculation will attract a mark, and then the SI unit, you making use of the correct SI unit for your final answer, will also attract some mark. So let's solve this. How do we make molar mass the subject of formula? This is over 1, you cross multiply. So we're going to have number of mole times molar mass is equals to mass. Okay? Remember, we are trying to find molar mass. So you divide both sides by number of mole. Number of mole. So if I divide number of mole by number of mole, then we now have our molar mass is equals to mass over number of mole. So we are going to use this to solve now. So our molar mass is going to be, what is the mass given? 123 divided by, what is the number of mole? The number of mole is 0.50. 0.50 is the same thing as 0.5. So if you're going to divide 123 by 0.5, that means our answer is going to be, you press your calculator, should give you 246. How do I know? 0.5 means half. 0.5 of 246 will give me, that is half of 246 will give me this. So I can be sure it's 246. The molar mass is gram per mole. All right. But note, we were asked to find the value of x. So the next thing you want to do is you now equate the formula M magnesium sulfate dot XH2O equals to 246. Magnesium has a molar mass of 24. You were given, so 24 plus sulfur is 32 plus oxygen is 16 multiplied by 4. 16 by 4 plus x into bracket. Hydrogen is 1 times 2, that is 2 plus 16. Oxygen is 16. So water is 18. So x into 18. All equals to 246. Right? Then the next, when you add this, you're going to have 56 plus 64 plus 18x equals to 246. If we add this together, we're going to have 120. 120 plus 18x is equal to 246. So this is going to move to this side. Then your 18x is going to be 246 minus 120. All right, 246 minus 120. So what is 246 minus 120? We're going to have 18x is equals to 126. 126. 126. Yes. Yes, that is 246. Yes. So now the next thing is to divide both sides by 18. So when we divide both sides by 18, our x is going to be 7. And that is the answer. Because 18 times 7, 8 times 7 is 56. This is 7 plus 5, 12, 126. So our x is 7. So the value of x is 7. So the question says calculate the value of x. The answer is 7. That is the answer. I hope that is clear. So that means the compound is magnesium tetraoxosulfate 6 heptahydrate. Hepta means 7. So 7 moles of water of crystallization, and that makes it heptahydrate. I hope that is clear. So you can pause this video, go over it again. I wouldn't want this video to be long, and I still have other topics to treat. So I'm going to stop at this second example. But if you still want to have deeper understanding on this topic of stoichiometry, I have done a lot of videos on stoichiometry. So you can head on straight to the YouTube channel, my YouTube channel. You will find more examples there. And of course, I'm dropping the link to those videos in the description to this video. All right, so now we're going to the second topic, which is I will talk about electrolysis. Let us talk about electrolysis. Now, under your electrolysis, I'll be talking about the calculation aspect of your electrolysis, where you'll be asked to calculate the number of mass of the substance that is deposited either at the anode or at the cathode. But before we go there, let me just give you some short reminder about questions that can come under electrolysis. So let's look at electrolysis. Now, the first question they can ask you is to define electrolysis. It is the chemical decomposition. It is the decomposition, okay, of a compound when the red current flows through it, either in its aqueous or liquid state. Now, panic means positive anode. So, anode is the electrode, the positive electrode. All right. Panic means positive anode, negative is cathode. So negative is cathode. That means cathode is the negative electrode, anode is the positive electrode. And ox. And ox means anode is where oxidation occurs. Why? We also have K. We have K or red cat. K means cathode is where reduction occurs. Cathode is reduction. These are questions they can ask you. They can ask you, where does oxidation occur? Is it at the anode or the cathode? Where does reduction occur? Then they will ask you that which of these occurs at the anode or the cathode. Is it electrons are lost or gained? They can ask you to explain what you meant by reduction. So I'm giving you the next one, oil rig. Oil rig means what? Oil rig means oxidation is loss of electron. Oxidation is loss. Rig means reduction is gain. So when you say oxidation occurs at the anode, that means at the anode there is loss of electron. Then at the cathode there is gaining of electron. So those are those main things you need to know. So the next thing we talk about, I'll quickly talk about the calculation aspect of electrolysis. The calculation aspect of electrolysis, then I will now go to how to know which ion will be discharged at the anode and the cathode. Once you know all of that, you are good to go with electrolysis, okay? About the calculation aspect of electrolysis, would they ask you how much of this, how was the mass of this substance that is deposited in the electrode? All right, so the formula, the shortcut formula I'm giving you is when you go to a mosque, you see a Quran, you see a wall, you see number of females. Take note of this formula. You know, we want to learn from the faith that goes to the mosque. When you get to a mosque, you see that the person leading the people in prayer, which is the imam, he has a Quran with him, right? And then you have men in front of him. He's standing in front of the men. The men are the ones in front. Then there's a wall of demarcation, and then the females are there. So you can learn from that to easily remember this equation in chemistry. So when you go to the mosque, you see a Quran. This Quran, but here it's Ram, right? Is with the imam, okay? That is why it's Quran, with the imam. Then you see the wall of demarcation, you see the number of females. What does each of these, what do they represent? Your M is the mass deposited. Mass deposited. Your Q is the quantity of charge, quantity of electric charge in coulombs. all right, which is also given as Q equals IT. So if you want to calculate your Q is IT, which is current times time. And then your RAM is your relative atomic mass of the substance given. And then the N is the charge on the ion that is deposited. And then F is your Faraday's constant. Which is always what? 96,500 per coulombs. All right, 96,500. All right, so we are going to use this formula right now to answer questions. Now they can ask you most questions, calculations they will ask you will be based on this, but they can also ask you, and this is from the second law of electrolysis, second Faraday's law of electrolysis. So from the first law, that's where you have your Q equals IT, your M equals ZIT. And because your Q is IT, M equals to ZQ. All right, where M is the mass, I is current, T is time, your Z is the electrochemical equivalent. So they can give you, so either of these equations you would use to answer any calculation question in electrolysis. So let's see an example of question you could be asked. Once we are done, then we will now talk about how to know which ion is discharged at the anode and the cathode. What mass of copper? So what are they asking us? Mass of copper will be deposited by a current. Our I, which is the current, is 1.0 amperes. Passing for, this is time is 965 seconds. Please note, they could give you this in hours, they could give you minutes. You must convert it to seconds. How do you convert to seconds? If they give you minutes, just multiply by 60. It will convert to seconds, because 60 seconds make 1 minute. So if they say 30 minutes, you multiply by 60 only once, it converts to seconds. But if it is hours, 2 hours, you are going to multiply by 60, then by 60 again. So you are multiplying that 2 hours, 2 times 60 times 60. All right? Don't forget that. So that is the time. True copper 2. Please look up here. Copper 2 tetraoxosulfate 6. Copper 2 tetraoxosulfate 6 means the oxidation number of copper is 2. So the N for copper is 2. Copper 2 tetraoxosulfate 6 solution. And then you were given this value is the RAM. The relative atomic mass of copper is 63.5. While the Faraday F is 96,500 coulombs. So can you recall the formula? We said when you go to the mosque, you see a gram, you see a wall, you see number of females. So they are asking us for mass. So just impute your values directly. Your Q will be IT, you remember? So that is I1 times T time 965 times the RAM is what? 63.5 divided by your N is the charge, 2 multiplied by your Faraday is 96,500. So if you punch all of this into your calculator, 965 will cancel 965 there, so I have 100 left here. So that is 63.5 divided by 200. All right, so that's going to be what? 0.3. That's going to be 0.3. Okay, or 0.3. Yeah, it's going to be 0.318. 0.318. Okay, so that is that's going to be the answer to the question. 0.318 grams. All right, that is the answer. 0.318 grams. That's the answer. All right, let us look at other questions that they can ask in terms of what will be deposited, what is happening at the anode and the cathode. Remember, the anode is the positive electrode, cathode is the negative electrode, anion is the negative ion, anode ion. All right, that's the meaning of anode. That is the negative that will migrate to the positive anode. Cation is the cathode ion that will migrate to the negative cathode. So itself is positive ion. I hope that is clear. Now